indices that you have to know. You must have heard MCV, MCH, MCHCS. When I'm talking about the RBC indices, I'll start off my story by making you understand what are two very important things called PCV and ESR. Before I go on to all those MCV, MCH and all, those are easy, trust me. I'm going to start off my story with PCV and ESR and listen to this very carefully. When I'm talking about PCV, so what I've done, I've taken a test tube over here, okay? I've taken a test tube over here and first I decided that let me fill it completely with blood. I filled it like I took 5 ml of blood sample from the patient and I filled it completely with blood. After that, I realized that if I spin it, what do you call it? Spinning is known as centrifugation. So if I spin this test tube, by the law of gravity, all of us know that all the heavy things are going to come and settle at the bottom. Or even if you don't spin it, you say, ma'am, I don't have that machine. Machine nahi hai. Let's not spin it. You just leave it. You leave it on one side. Don't you think by gravity, all the things are going to settle at the bottom? What are the heavy things? All the heavy things are known as the red blood cells. So I will say that yes, all the red blood cells have packed at the bottom. Initially they were till here, initially they were till the top, but gradually they decided to settle down. They have all packed till the bottom. They have gone all the way down and packed over here. Can I say that this much of area can then be defined as a packed cell volume? This can be known as packed cell volume, and you know packed cell volume is nothing but the hematocrit that I have been talking about. So PCV and hematocrit means the same, and the word tells you packed cell. What is getting packed? The red blood cells are getting packed, and this is roughly around a 45%. So out of the entire blood, now you'll ask me what is the entire other blood? The other part of the blood that you're talking about over here is all going to be the plasma. All of it is going to be the plasma part of it. And what do you have at the bottom? Packed at the bottom, packed cell volume. Simple. But now tell me, the column has fallen. Initially the blood was still here. Initially the blood was at this level. It has gone all the way and settled at this level. Can I say there has been a fall? Dhyan se dekho. Initially the blood was at this level. Now it has gone and fallen all the way up till this level. So sediment hua hai. The blood has sedimented. This is known as ESR. ESR stands for erythrocyte sedimentation rate. Erythrocyte sedimentation rate. So please remember, the red blood cells, whatever is packed at the bottom is packed cell volume. Whatever is settling from above down, that is ESR. Let me show you the same thing with an actual picture that I'm trying to show you. So have a look at this. What is this tube? This tube in which I can see both the things is known as a Vintrob's tube. This is referred to as a Vintrob's tube, where you can very well see what is this going to be. Roughly, dekho 4 and 5 ke beech mein you are getting the marking 45%. What is this? This must be the packed cell volume. Means now if you look carefully, there are two readings. You'll say, ma'am, which one to consider? One reading is going from 0 to 10, means it is going from below upwards I can read, and one reading is going from 0 to 10, which I can read from above downwards. Why? Because in the same tube, can I measure the packed cell volume on one side, and can I also measure the erythrocyte sedimentation rate on the other side? Let's try and analyze this for ourselves. Dekho, when I want to measure the packed cell volume, I will read, okay, 0, 1, 2, 3, 4, 4.5 per hour hai. So what is the packed cell volume of this person? The packed cell volume of this person is 45%. How easy to know. Next, when I want to measure the erythrocyte sedimentation rate, I don't give percentages. Erythrocyte sedimentation rate, I measure on the basis of how many mm per hour. At the end of 1 hour, how much of it has sedimented. So the reading that I take from top to here, from 0, 1 to 3 like this, that is going to be the ESR. So now you understand why the same tube has two readings. Repeating it once again, the same tube, as you can see, one set of readings are from below upwards. That is going to help me analyze the packed cell volume. One reading is going to be from above downwards, and that is going to help me analyze the erythrocyte sedimentation rate. Let me give you a real-time example. This is what I got in my lab. This is a tube that I've got from my lab. Firstly, this is the Vintrob's tube, and in this Vintrob's tube, I just wanted to make you analyze. Can you tell me what is the hematocrit? Dhyan se dekho, labelings 0, 1, 2, 3, 4, and somewhere over here 42, 43% must be the hematocrit, normal. 42% I gave to the patient, he was having a normal hematocrit. Yes, everyone's been able to analyze. So what are the uses of a Wintrobe's tube? A Wintrobe's tube is going to be used for the estimation of PCV or hematocrit, the bottom part, and it is also going to tell me how much of it has fallen. So it is also assessing the erythrocyte sedimentation rate. What else can I analyze? Dekho, till the time it was normal, normal blood 45% roughly, normal blood is 45% hematocrit. Suddenly I say that the hematocrit has become 20%. What will you say? Oh, RBC has gone down, packed cell volume has gone down. This must be a case of anemia. Red blood cells are less. This is a case of anemia. And if I say the packed cell volume is a 55 or a 60%, you'll say the red blood cells are too many. Red blood cells are too many means what is it a case of? It is a case of polycythemia. So see, in the same test tube, so many things I can analyze. 45% hai. If it is 45% normal, suddenly I say no, it has become only 20%, means gone, anemia. And suddenly it has shot up, it has gone to 60%, means this is a case of excess red blood cells, this is a case of polycythemia. So see that one tube is giving you so much of information. Moving on to the next, not only do we analyze Wintrobe tube, there is also something known as Westergren pipette. There is also something referred to as Westergren pipette, and this you don't do for packed cell volume, this you only do for ESR assessment. Pehle to the two main differences that I just told you. Wintrobe's I was calling it as a tube. Wintrobe's I was calling it as a tube because my concept of a tube is that one side of it is open and one side of it is closed. Test tube kaisa hota hai? One side is open, one side is closed. So that is a test tube. When I'm talking about Westergren, Westergren is a pipette because it is open from here also and it is open from here also. So please note, Westergren pipette is known as a pipette because it is open at both the ends. I have just kept it in my blood sample over here, but ideally it's open from both the ends, and this only measures ESR. Wintrobe tube was measuring both. Wintrobe tube could measure ESR as well as PCV, whereas Westergren is only and only going to measure how much of the blood has fallen down. That is, how much of it has fallen down. That is the Westergren pipette. One more difference, if I think a little from Ratta point of view, I will know that Wintrobe is the shorter name. When I have a chota wala naam, that I have a chota wala tube, right? And Westergren, many books write it, the way it's written over here, Westergren tube is written, tube nahi use karna. What should you be calling it? You should be calling it a pipette because it's open from here also and it's open from here also. And look at the name, it's Westergren pipette, itna lamba naam, so the tube is also going to be very, very long. So if they ask you, how are you going to differentiate between Wintrobe and Westergren? You give them a simple reason that Wintrobe is a small name, so it's a small tube. Westergren is a big name, so it's going to be a big pipette. You can see the labelings also. Wintrobe is a smaller tube, so we see that the labelings are only till 10, so 100 mm. And Westergren is a bigger tube, so the labelings are going to be till here, till 200 mm the labelings are. So definitely something that I can see. Wintrobe chota, Westergren bigger. What about next? Where will you use more amount of blood? Obviously, less amount of blood is going to be used in Wintrobe because it's a chota tube, and more amount of blood is going to be used in Westergren. So when you are using more amount of blood, which is going to be a better technique, better sensitivity will be obtained when you've analyzed a bigger sample. The bigger the sample that you analyze, the better results that you will get. So Westergren, the longer one, gives you better results. Next, they will ask you that for testing ESR, for example, देखो दोनों में common क्या है? Wintrobe was having an advantage that it can test both PCV and ESR. Westergren is only for ESR. So what is common? I can compare the ESR of both. So if I have to basically measure the ESR via Wintrobe's versus ESR via Westergren, your basic practical problem is that, ma'am, my path lab, the hospital that I am working in, my path lab does Wintrobe's. One intern comes to me saying that. The other intern says, no, ma'am, in my hospital, Westergren method is done. So I am an intern. My job is to collect a blood sample. In which vacutainer should I collect a blood sample? So Wintrobe's ke liye the anticoagulant is EDTA. Anticoagulant is EDTA basically means you are going to use the lavender vacutainer, the purple lavender vacutainer. Whereas for Westergren, it is going to be trisodium citrate. It is trisodium citrate. Guys, trisodium citrate is the light blue color vacutainer that we have. We will be doing vacutainers right at the end when we go for, the miscellaneous things like blood banking and vacutainers. But before that, please analyze. We are talking about Vintrobe, chota wala tube, chota wala anticoagulant. I'm going to use EDTA blood in this. Whereas when I'm using Vestergren, the long tube, I'm going to use such a long name of the anticoagulant, trisodium citrate. That anticoagulant blood is used in Vestergren. Are we okay with these? These are very basic things to start off with, and more I'll be talking about it as we go. But there's one thing more. Right now, these two I am only using if I have a path lab in my hospital. You say that, ma'am, once I send the sample to the path lab, pathologist, so everyone likes bashing up the pathologist. You like pathologist, nahi tha, pathologist don't do any work, this and that. He was not there on a night duty and he was not available. I did not get my report. So I'll say, why don't you start doing this bedside? It will be beneficial for the patient. You'll get the result in 2 minutes or 1 hour or half an hour. After that, otherwise, if you send it to a path lab, it's going to take time. So what are you going to do? There is also something known as microhematocrit. What is microhematocrit? You are doing the same thing. You will take a blood sample. You will see how much of it has settled. But that blood sample is being collected in a very, very thin tube called the capillary tube. The sample is being collected in a very thin tube called the capillary tube. So you will collect the sample and then see you've kept it for 1 hour on the side. You've kept it for 1 hour on the side because at the end of 1 hour, what do we have? At the end of 1 hour, you will be able to see what all is the blood that has come at the bottom. At the end of 1 hour, you will be able to analyze the hematocrit or the packed cell volume. But you are doing it, to hematocrit to mila. But you are doing it in a very chota wala capillary tube. Remember the tubes you used to use for BTCT in your physiology practicals? Wo wala, patla tubes. So what are you going to call it? You're going to call it microhematocrit. Everyone's okay? So microhematocrit is something that we can use as a bedside process. Very, very important. Very commonly you will find these. And now this, I'm telling you, a very rich setup where you have a stand where you can keep those tubes. In the hospitals, you are not so rich, especially in government hospitals. So, you'll see that on the walls, they have stuck these tubes with leucoplast ke saath unhone stick kar diya hai. Why? Because for 1 hour, they had to keep it upright. Where should they keep it upright? So they decided, okay, we'll stick it onto the walls and after 1 hour, we'll take the reading. That is how they do the kind of, solution to a problem. They have to find out. Okay, so all said and done, all of these were measuring not only PCV, but they were also measuring the fall. And what was the fall known as? The fall is known as ESR. ESR means we are talking about erythrocyte sedimentation rate. We are talking about erythrocyte sedimentation rate. So how is the erythrocyte going to sediment? So for example, if this is a tube, you will say the blood has to fall down, but it's not going to fall down like sudden collapse. The lift is not going to collapse on its own. If the blood was up till here, how will it gradually come and settle in this much area? How will that happen? That will be a process. So remember, the first stage is the stage of rouleau formation. The first stage is the stage of rouleau formation, or in other words, if I want to simply say aggregation, if I want to give it a very, very layman term, aggregation, which takes approximately 10 minutes. And what do I mean by that? Initially, all the cells were aisa alag, red blood cells were all separate, but after 1 hour, when I've left them undisturbed, they will start making small aggregates. First, they decided that let us make small groups, study groups, 3-4 ka study groups we should make. Okay. After they made this, how much time does it take? Making a study group is very simple. Leave a message on Telegram. Study partner needed, kindly DM. So 10 minutes mein ho jata hai. That study partner, chota groups are done. After that, we have the second stage. In the second stage, what is going to happen? All these study groups decided that, they met each other in the library and all of them have made a big clump and settled at the bottom. So what is going to happen to all these study groups that you will eventually realize? In this entire test tube, all these study groups have started sedimenting. They have started making one mega study group. So what is this known as? This is the stage of sedimentation or settling. This is the stage of sedimentation or settling. And this is going to take time because so many people have got together. This is going to take 40 minutes. So many people, so many chota study groups are coming together. So this is going to take 40 minutes. And finally, then they say, Arey, so many people, we to can't study. When 40, 50 of you get together, will you be able to study? You won't be able to study. It is all going to go puss. Puss matlab the study plan is going to go off. So what has happened? What has happened is all of them have ultimately packed. They are packed and puss matlab they have all packed into each other, and that is known as the stage of packing. And this is also going to take 10 minutes. So overall, did I always keep on saying leave the tube for 1 hour, leave the tube for 1 hour? Why did I keep saying leave it aside for 1 hour? Because the total time needed for the red blood cells to settle down is 1 hour. So what are the total phases that you had? The phase number 1, let's repeat. First phase was making chota groups. Chota groups was making micro aggregates, making rouleau formation. That is the first stage. After that, all those groups are going to settle down. All those groups are gradually going to settle down a little and come to the bottom. And after some time, they say, okay, it's time to pack. Pack in the bottom. So 10, 40, 10. 10, 40, 10 makes it 60 minutes. So we always analyze erythrocyte sedimentation rate at the end of 60 minutes. What are the two tubes that can measure it? We can measure it via Wintrobe also. Wintrobe I would want to call as the tube, and I can also measure it via Westergren. Westergren I will want to call it as a pipette. Both of them can measure ESR. So your next question will be, when is ESR going to increase or decrease? That part I will come to in a while, because as I tell you the different stages and the different diseases, I will teach you all the ESR changes that are going to happen, right? For the time being, you have done 2 indices. What all have you done? The 2 major ones. You have finished off what is this packed cell volume. You have also finished off how the ESR is falling. Now you go on to the others. What is MCV, MCH, MCHC and RDW? The 4 main, and we are sorted with this. Firstly, when I say MCV, MCV stands for mean corpuscular volume. Mean corpuscular volume mainly means that you have a mean, an average. Corpuscular means red blood cell, and volume means size. You have taken out an average of everything. So for example, if one red blood cell is of say size 10, one is of 5, one is of 7, one is of 8, one is of 2, so sabka alag alag size, I will take out one average out of it, and this average is known as a mean corpuscular volume, or MCV, and the normal value of MCV is 80 to 100 femtoliters. Robbins mentions 82 to 96. Itna intricate is not needed. 80 to 100 round off karke you can learn, and that is femtoliters. That is very important. Students usually mess up with their the units. FL stands for femtoliters. That is mean corpuscular volume, is giving you an average size. On the other hand, we have 2 molecules with, or 2 parameters with H, that is MCH. MCH stands for mean corpuscular hemoglobin, and MCHC kya hoga? It's the same, mean corpuscular hemoglobin. I add a C in front of it, and that is concentration. So one is mean corpuscular hemoglobin, one is mean corpuscular hemoglobin concentration. So what is this? One of them is measuring the hemoglobin per red blood cell, and one of them is measuring hemoglobin in the entire hematocrit. So repeating, one of the values is measuring hemoglobin in each and every red blood cell, and one of them is measuring hemoglobin in the entire hematocrit. What are their values? Remember, I start from 27 and I will end at 37. That is how I have learned it. MCH and MCHC start from 27, end at 37, break in the middle, break at 32. So 27 to 32 and then 33 to 37. Easiest way of learning. 27 to 32, then 33 to 37. Units are important. 27 to 32 picograms is MCH and MCHC is 33 to 37 gram per deciliter. Units yaad rakh lena, that is most important. I want all of you to do a very, very rapid recap, because after this I'll be able to tell you some normal questions also which will help you. So repeating all of this once again, when I start with this entire story, can you tell me what is the normal MCV, what is the normal MCH, and what is the normal MCHC? Because then I will tell you variations. When I say MCV, all of you are saying that this is going to be 80 to 100 femtoliters. And what does it tell you? It tells me the size of the red blood cells. Can I call the normal size as normocytic? Can I say normal size? 80 to 100 is normal size, na? Normal size matlab normocytic. So if I say it will be less than 80 femtoliters, what will you call the red blood cells? They become chota, they become small. Will you call it microcytic? If I say they've become more than 100 femtoliters, they've become big, ma'am. Now you call it macrocytic. So now you've understood how we do those macrocytic anemias. You do it on the basis of these MCV. Normal MCV is 80 to 100. Less than 80 is microcytic. More than 100 is macrocytic. Now tell me the normal values of MCH and MCHC. So normal value of MCH was what? Start from 27, end at 32. 27 to 32 picogram. MCHC is 33 to 37 gram per deciliter. So now, what is this telling you? Hemoglobin. Both of these are telling you some element of hemoglobin and hemoglobin concentration. So, socho, hemoglobin is color, na? When the hemoglobin is normal, when this is normal, I will say normal color, normochromic. But if the MCH is less than 27 picogram, I will say the color is less. The color is less. This is going to be hypochromic. And if it is more than 32 picogram, I will say the color is more. This is going to be hyperchromic. This is going to be hyperchromic. So now let me see how many of you have been able to analyze. Let me give you a little bit of a tricky question. I say there is a female who has a hemoglobin of 6.4 grams. Of course, that's a case of anemia that you have. Her MCV has come out to be 62 femtoliters. Her MCH has come out to be 21 picograms. Her MCHC has come out to be 29 gram per deciliter. What is your anemia diagnosis? Firstly, is it a case of anemia? Yes. This tells me that anemia to definitely hai. But microcytic, hypochromic. So MCV was 80 to 100 was normal. 62 to matlab it is less. This is a microcytic anemia. Microcytic. When I say MCH was 27 to 32. Yahan par MCH is coming out to be less. So this is hypochromic. What kind of anemia is it? This is a case of microcytic hypochromic anemia. Has everyone been able to analyze this? If I would have said her MCV is 110, if I would have said her MCV is 110, what anemia would you have called it? 110, big size, macrocytic. That is how you do the analysis. So remember these guys. Remember MCV, MCH and finally MCHC. MCHC tells you the hemoglobin concentration. Right now I can't explain this concept because you've not studied the anemias. But please remember MCHC shall be elevated in an anemia called hereditary spherocytosis. Please mug up this information for the time being, and I promise when I go to hereditary spherocytosis, I'll explain the entire logic behind it. Abhi ke liye ratta laga lo, it's elevated in HS. Coming all the way back, you are done with your three main parameters, and now you are going to understand the last parameter which I want all of you to know is RDW. What is RDW? It is a red cell distribution width. It is a red cell distribution width, and this measures, listen to me very carefully, this measures a variation in the size of the red blood cell. Variation in the size of the red blood cells. Now, as soon as examiner says the word size, please note what is the examiner trying to tell you. Is the examiner asking me the size? What parameter? I will mark MCV. If only size is asked, I will mark MCV. Simple. But if the examiner ends up asking me variation in the size, then what will I mark? Then I will mark RDW. Means if I say, what is your height? You say your height is 5 feet 5 inches. Means I'm measuring your MCV. I'm trying to find out your height. But if I say, let's take all 100 students in this class and let's see what is the variation. Someone might be 5 feet, someone might be 6 feet, someone might be 5.5 feet, someone might be 5 feet 8 inches. Variation, everyone is of different heights. So that variation that I'm trying to measure, that is going to be RDW, hai na? So if I ask you single height, I'm asked size, that is going to be MCV. If I ask you variation in size, that is RDW. Please remember, variation in size of the red blood cells is known as anisocytosis. Anisocytosis is a variation in size. So indirectly you get a question in the exam. RDW is a measure of what? It is a measure of anisocytosis. And what is the normal value? The normal value is 11.5 to 14.5%. That's the normal value 11.5 to 14.5%. So if I say someone has an RDW of 16%, means there is a lot of variation, chota, big, medium, all sizes are seen, lot of variation is seen over there. And that diseases I will be telling you in a while. Of course, we'll be studying everything. So all your parameters are done. Now, what all are you done with? You are done with MCV, MCH, MCHC, you are done with RDW, you are done with packed cell volume, and done with ESR. All of these are done, which means you are ready for this table over here. When I talk about MCV, 80 to 100 femtoliters. MCH, 27 to 32 picogram. MCHC, 33 to 37 gram per deciliter. Packed cell volume, roughly around a 45% is what I've learned. RDW, 11.5 to 14.5%, and ESR is done by 2 tubes, and either that is called as the Vintrobe, which I call as a tube, or I can do it by the Westergren, that lamba wala, that long one is known as a pipette, because that is going to be open at both ends. That is your summary that you have done up till now, and now you are ready for your peripheral smear analysis. That's the last part that we all have to know. How is this going to look like? Have a look at this, guys. Look at this. How do you do peripheral smear analysis? So in the exam, till the time the values was given, okay. Now the values have gone, okay, and now I have a picture in front of me. Now I can't measure 80 femtoliter, 27 picogram, I can't measure anything. So what do? Let me do a smart trick. Let me find a lymphocyte in the sample, because I know that nucleus of a lymphocyte is definitely going to be what? It is going to be 7 microns, and I know that size of the red blood cells is also going to be 7 microns. So now when I don't have a scale to measure, I can do this trick that red blood cells should ideally be equal to the size of a lymphocyte. Now if I try to compare, can you tell me? Look at this tiny little cell here, and this tiny little cell here, and tiny little cell here. Are they equal to the size of the lymphocyte, or are they looking smaller? They are looking smaller. So can I call these as microcytic? Can I say these cells are microcytic? Everyone's analyzed. How do we do the analysis? Let's do a very quick recap. You are always going to measure what? You are going to find out a lymphocyte. You will first find out a lymphocyte. Equal hai to 7 microns equal hai. Agar smaller hai, it is microcytic. How do you analyze hypochromic? So please note that for knowing hypochromia, central 1/3 pallor is normal in a red blood cell. Central 1/3 pallor is considered as normal in a red blood cell. Means whenever you're drawing a red blood cell, the central 1/3 is definitely going to be khali. It's going to be khali only. That is normal. But suddenly I say that the entire, so this is normal, not a problem. But suddenly I say the entire, more than central 1/3 pallor, more than 1/3 pallor. Now it's looking very white. It's looking very khali. What do you want to call it? Now you want to call it hypochromic. So how do you analyze hypochromia? More than 1/3 pallor, more than 1/3 area. Look at this cell. So this cell, hardly any hemoglobin is seen. Pura hi it is looking khali. This is also looking khali. These are looking very, very white in the center. These are all looking very, very white in the center. Means these are all your hypochromia cells. Have we all analyzed how to look at microcytic hypochromic? For mentioning the size, you will compare it with a lymphocyte. And for measuring the color, you will see central 1/3 is normal. Anything above that is definitely going to be one of your hypochromia things. Okay, now one last thing that you all have to know is how are you going to differentiate between two terms that you have very commonly that you use in this condition, anisocytosis and poikilocytosis. These are the two terms that you have to know. How do you differentiate aniso and poikilo? Anisocytosis is going to be a variation in what? It is a variation in the size of the red blood cells, right? Whereas poikilocytosis is going to be a variation in the shape of the red blood cells. It's a variation in the shape. Repeating, when they talk about anisocytosis, it is aniso, it is variation in the size of the red blood cell. Whereas when they talk about poikilocytosis, variation in shape. So was that previous smear showing me anything like this? Could you see some variation in shape over here? Could you see over here, this was a case of what? A pencil cell. I can see a pencil cell over here. As soon as I'm seeing a pencil cell, this means that, yeah, there is poikilocytosis present. That is how I'll be doing the analysis. This is just very basic because actually, you know, this is a case of iron deficiency anemia, and that is exactly what I'm going to teach you next. For this slide, only thing I wanted you to know, how do you test the size? By comparing it with what? Question number 1, lymphocyte. How do you compare the color? How much of white area is normal? Central 1/3 white area is said to be normal. We have finished our discussion